Welcome to chapter 6.3, where we talk about decision algorithms. So again, this is another counting technique that we are learning in chapter 6 that will help us in the following section and in the following chapter. So one thing we're going to do first is something called the addition principle. Hence, we are going to add somewhere in our mix. So it says, when choosing among our disjoint, so they have nothing in common, disjoint alternatives, we add all the outcomes together. So think about what alternatives mean. Alternatives, we can talk about being not solutions, choices, options, anything that says, hey, we have a few choices, a few options, a few things that you can select from. There's no pressure to actually have a requirement option on there. So for example, it says at a restaurant, you can choose among 8 chicken dishes, 10 beef, 4 seafood, and 12 vegetarian dishes. What is the total number of dishes to choose from? So they're not telling us, hey, you have to do this, this, and this. No, they're just saying, hey, what are the total number of options of dishes that you can choose from? Your different alternative, your different choices. So if we get your 8 chicken plus your 10 beef plus your 4 seafood plus the 12 veggie, then we get 34 different dishes. So of my 34, I might end up picking just one of them, right? But I want to know, hey, what are all the different things that I can choose from? So that is if they have just alternatives. Now we're going to get into something a little bit more where we have multiplication principle, where instead of adding, we're going to multiply. So it says, when making a sequence, big takeaway is a sequence of choices, we multiply the outcomes. So you're forced to make one choice after another. We multiply. So something that says a sequence of choices is a requirement. Make more decisions. Big takeaway, is it required or is it just an option? So let's look at example 2. It says, at a restaurant, you can choose among 5 apps, 34 dishes, or 34 mains, and 10 desserts. What is the total different number of meals? Now, in your meal, you're going to choose an app, a main, and a dessert. So create all of the different meals that you can have. Well, we're going to multiply your 5 apps by your 34 mains by your 10 desserts. So you get 1,700 different meals, right? So perhaps on this sheet, let's say you're choosing between a meal that comes with a side and some sort of a drink. So I could choose a pizza, fries, and a fountain drink, or pizza, fries, and milk. Pizza, fries, and chocolate milk. And you can make a whole bunch of different meal combinations just throughout those alternatives. Whereas if we're just talking about these different sort of meals, perhaps you had a different sort of combo that you can just not deviate from, then we can add there. So looking at example 1 and 2, what is the primary difference? Other than, oh, we just add or, oh, we just multiply. Well, a meal consists of more than just one thing, right? You have to make one choice after another, whereas up here, we're just looking at the dish themselves, one that has some chicken, some beef, some seafood. We're not required to make a choice after another after another. It's just at its most basic. Now, before we move on to your next example, I want you to write somewhere on the page, is it required or optional? Or you might add. The it that I'm talking for is whatever action there we're doing. Is it going to be a forced thing or an optional thing? So in example 3, it says you walk into an ice cream, and I want you to visually go there, right? You walk into your favorite ice cream spot and you find that you can choose between ice cream, of which there's 15 different flavors, and frozen yogurt, of which there are 5 flavors. In addition, you can choose among 3 different sizes of cones for your ice cream or 2 different sizes of cups for your yogurt. If you want only a single item, how many different desserts can you choose from? All right, so we walk in to the store, right, to the ice cream spot. What's the first thing you need to decide right off the bat? You either get ice cream or you get frozen yogurt. You have an alternative number 1, ice cream. So that's your first decision. Or your second alternative is frozen yogurt. So let's hone in on the ice cream. Let's say you walk in, you picked trying to have an ice cream. Okay, so you know you want ice cream. Now what? What's the next thing you have to choose? You're going to pick a flavor. Okay, so how many flavors are there? They said there's 15 different flavors of ice cream. Now, is it a requirement that you pick a flavor? Well, of course, you're trying to go with ice cream, so you're forced to pick a flavor after you've decided on ice cream. So you've picked a flavor of which it's required. Then what? You pick a flavor, then you pick the size. For ice cream, how many different sizes are there? There's 3 different sizes. Okay, again, was it a requirement that you picked a size? Of course it's a requirement. Now, if it's required, what do we do? Is it multiplication or addition? It's going to be multiplication. So 15 times 3 gives us 45 different choices or options. Vanilla small, vanilla large, vanilla medium, chocolate small, chocolate large, chocolate medium. And you keep rolling on, right? With all of your 15 flavors. So there's 45 different choices you can make just for the ice cream side. So pause and try it again, but on the frozen yogurt side. So frozen yogurt, we said pick a flavor. Five different flavors. Pick a size, of which there's only 2 sizes. Both are required, so we multiply. Now I'm going to put this multiplication here. I would highly encourage you to do so as well when you look back at your notes. So now there are 10 different choices or options. Now, how many total options are there? Well, you can either have scenario 1 or scenario 2. So we're going to add between the two here. 45 plus 10 is equal to 55 total different desserts. So I would like you guys to try example 4 alone. In example 4, it says an exam is broken up into two parts, part A and part B, both of which you are required to do. In part A, you can choose between answering 10 true-false questions and answer 4 multiple choice questions, each of which has 5 answers to choose from. In part B, you can choose between answering 8 true-false questions and answer 5 multiple choice questions, each of which has 4 answers to choose from. How many different collections of answers are possible? So right off the bat, we have a choice. We can either do part A or we can do part B. So in part A, it says you can choose between answering 10 true-false questions. So true-false has how many options? 2 options. So for an example, let's say question 1, 2, 3, and all the way to 10, right? True or false, true or false, true or false. Down here, true or false, right? The first one has 2 options. The second one, also 2 options. The third, also 2 options. And all the way down to 10, we have 2 options. So how many total options do we have? Well, just as our last section in chapter 6.2, we said we're taking the total number of options, we're raising it to the number of questions, the number of tosses, the number of whatever can change. So it's always the questions above, and here it's the options as your bases. So 2 to the 10th. Okay, so we can either do true, false, or we can do a multiple choice, or let's see, how many multiple choice? 4 multiple choice questions, each with 5 options. Okay, so again, a small example. 1, 2, 3, and 4. A, B, C, D, and E. A, B, C, D, E. A, B, C, D, E. A, B, C, D, E. Okay, so this first one has 5 options. This next one has 5 options. Next one has 5 options, and the last one has 5 options. Right? So we have 4 questions, each with 5 options. 5 options, each with 4 questions. Okay. So we have 5 to the 4, 624. Now, is it a requirement that we do the true, false, and then the multiple choice? Or is it optional to pick between the 2? Well, if these are optional, either or, it's a choice, it's optional, we're going to add these 2 values together. 1649. Okay, let's do it again. Part B. So pause the video if you haven't done so already, see what you can come up with. Let's see, where was I? How many? 8. We have 8 true, true, false questions, each with 2 options. 2 to the 8th, 256. And then again, 5 multiple choice questions, each with 4 options. So 4 options, those options don't change, the questions do change. There you go. Again, was it a requirement to do both, or is it an alternative? Alternative number 1, alternative number 2. So we're going to add on these ones. There we go. All right, we're almost done. Right, we had part A, we finished that out, and then we finished out part B. So now it begs the question, is it optional to do A or B, or are we required to do part A first and then part B? Well, we're required to do both. It has 2 parts, part A and part B, both of which you are required to do. So if it's a requirement, what are we going to do with these 2 remaining outcomes? Required, A and B, we're going to multiply. Where do I have that? There we go. 2 million. 720. Oh, 720. And there you go. These are just different answers, different collections of answers. All right, so now comes to one last remaining counting technique. This is called a decision algorithm. Which is a procedure in which we make a sequence of decisions. This is a visual representation of possible decisions being made. So, for example, it says your local Apple store has iPads in 2 sizes, the larger Air or the smaller Mini. So this kind of helps a visual sense of getting all of your options together. So imagine yourself walking into this particular store, right? You can either make one choice or another. When you first walk in, you have to buy a product, some iPad. So you can either go with, we said an Air or a Mini. So you make your choice. You go with, let's say, the Air. The Air is available in blue and green. Okay, so then you choose the Air. Now you have to choose a color, either blue or green. So at the end, you could have a blue Air or a green Air. So you could have those 2 choices if you went with an Air. Or if you go with the Mini, your Mini comes in blue, it comes in green, it comes in pink, which I don't really have pink. We'll use this as pink. And it comes in purple. Choice 4, purple. So at the end of the day, you could have a blue Mini, a green Mini, a pink Mini, or a purple Mini. all you're doing when you finish out these decision trees, whatever decision you have will make a new branch. You're moving from left to right. And when you run out of those options, then you have your outcomes, of which how many total outcomes are there? 6 total outcomes. 6 total different outlooks of your options. So that being said, can you try example 6? Practice making a decision tree. You walk into a local small coffee shop. You can choose between coffee or tea. They have 3 flavors of coffee: regular, vanilla, and hazelnut, and 3 sizes: small, medium, and large. They have 2 flavors of tea, green and black, and only 2 sizes for tea, small and large. What are all of your options? So your first decision when you walk in, you can either have coffee, coffee. So you have coffee. Now, if you go with coffee, you can do regular, you can do vanilla, or you can do hazelnut. You can also have 3 sizes: small, medium, large, small, medium, large, small, medium, large. So this one will produce a small, regular coffee, a medium, regular coffee, a large, regular coffee, a small, vanilla coffee, a medium, vanilla coffee, and a large vanilla coffee. Totally did not give myself enough room. Let me move this down a little bit. There you go. Okay, a small hazelnut coffee, a medium hazelnut coffee, and a large hazelnut coffee. So far you have 1, 2, 3, 4, 5, 6, 7, 8, 9 options here for the coffee. So 9 coffee options. You could also go with tea. You could either have green and black. You could then go with 2 sizes: a small, a large, a small, a large. You can end up with a small green tea or a large green tea, a small black tea or a large black tea. So you could have a total of 1, 2, 3, 4 tea options. Your total number of options would be 13 total options to choose from on a daily basis. This is what they would all look like if you were to bring them all together. So hopefully decision tree you feel comfortable making. These are sometimes really helpful for visual learners. Same thing when we're doing coin tosses, you're going to see me make a lot of these because it's hard to come up with all of them, especially if you're making 3 to 4 to 5 coin tosses. We're going to be missing some.